Have you ever wondered where does the tuna we eat come from? The methods by which tuna reaches our plates are as diverse as they are distinct, with tuna farming and tuna wild fishing representing two contrasting approaches. In the case of tuna farming, juvenile tuna have specific dietary requirements that must be met to support their growth and development. For that, efforts are made to replicate their natural diet by offering live or frozen prey items and stimulate the fish's natural feeding instincts. Due to the high investment involved in tuna farming because of its large size, a cost-saving solution has been found. Pelleted feed for tuna is specially formulated to meet the nutritional requirements of the fish at different stages of their life cycle. It is manufactured so they resemble their natural prey, as tunas are very picky about their food. If they did not look like them, these pellets would be left floating in the water. Once tuna reach market size, they are selected as harvest candidates based on predetermined criteria such as size, weight, and market demand. Fish that meet these criteria are chosen for harvest, while smaller or lower quality fish like this one may be left to continue growing. Once the tuna are deemed ready for transfer, they are prepared for larger grow-out facilities, acclimating the fish to changes in water parameters to minimize stress during the transition. On the other hand, we can also find tuna wild fishing, which dates back thousands of years, with evidence of tuna being harvested for food and trade by the Phoenicians, Greeks, and Romans. What we are seeing now is called longline fishing. It is one of the most common methods used to catch tuna commercially. This method can be highly selective, allowing fishermen to target specific sizes and species of tuna while minimizing bycatch of non-target species. Once bled, tunas are gutted and cleaned to remove internal organs and any residual blood or viscera. By placing them immediately in ice slurry, they rapidly lower their body temperature and slow bacterial growth, extending its shelf life during storage and transportation. However, in some cases, The tradition is maintained and pole and line fishing is practiced. Fishermen use techniques such as chumming, which consists of dispersing bait into the water. By targeting tuna schools near the surface, habitat disturbance is minimized, avoiding damage to sensitive benthic habitats such as coral reefs or deep-sea ecosystems. Once the fishing vessel returns to port, the containers of tuna pieces are transferred to larger transportation vessels for shipment to auction facilities or processing plants. Tuna species vary in size and weight, with some species growing larger than others. For example, Atlantic bluefin tuna is one of the largest tuna species. It can reach lengths of over 10 feet and weigh several hundred pounds. As they are so big, throughout the transportation process, maintaining the cold chain is crucial to preserving the freshness and quality of the tuna pieces. Tuna auctions are fascinating events where the finest pieces are sold to the highest bidders. Upon arrival at the processing facility, harvested tuna is inspected for quality, freshness, and compliance with regulatory standards. For that, in most cases, a small piece is cut so that retailers can assess the quality of the flesh. The weight of each tuna piece is recorded along with other relevant information, which is documented on auction sheets or electronic systems for reference during the auction process. And here's the kicker. Depending on market demand, stocks can go crazy. In fact, in January 2019, a 612-pound bluefin tuna was sold at the first auction of the year at the Toyosu market, setting an absolute record. The winning bid was a staggering $3.1 million, making it clear why this fish is called the diamond of the sea. With sharp knives, skilled workers carefully remove the stomach, intestines, liver, and other internal organs without damaging the tuna meat. Depending on the intended use, tuna fillets can be portioned into various sizes and shapes to accommodate different recipes and serving styles. Tuna fillets may contain pockets of fat or connective tissue that can affect texture and flavor. That is the main reason for trimming. By removing excess fat and any tough or undesirable portions from the fillets, its overall quality is improved. Now, the tuna industry goes much further. Tuna can go through several processes that make its preservation and subsequent consumption much longer. In the case of fresh tuna, the sale and consumption is immediate, but one of the most common ways of selling tuna is in cans. Tuna intended for canning is often caught and processed on fishing vessels or at sea-based processing plants. The global canned tuna market is substantial, with billions of dollars in annual sales revenue. According to market research reports, the canned tuna market is valued at several billion dollars and continues to grow steadily due to increasing demand from consumers worldwide. In regions where tuna fishing and processing are major industries, thousands of jobs are created in fishing fleets, processing plants, canneries, and related sectors. In some countries like Japan, Mexico, or Spain, the canned tuna industry is a significant source of livelihood for coastal communities and rural areas. Large-scale processing facilities typically handle large volumes of tuna from various sources, requiring efficient weighing and sorting systems to manage the incoming fish. In this sense, there is one process that is paramount to prepare the tuna for further processing. Thawing involves gradually raising the temperature of the frozen tuna to defrost it safely and efficiently while minimizing the risk of bacterial growth and quality degradation. Water temperature is closely monitored to ensure that it remains cold and within food safety guidelines. In many cases, as you can see, the thawing and filleting process is done at the same time to optimize processing times. It has become clear that water is an essential resource in tuna cutting operations. Industrial tuna cutting facilities implement water recycling systems to minimize water consumption and reduce wastewater discharge. Recycled water is treated and reused in various stages of the cutting process, helping to conserve water resources and reduce operating costs. Then, the filleted tuna is sorted according to its classification to be cooked. Most processing facilities use steam cookers, boiling tanks, or pressure cookers. The method chosen depends on factors such as the desired texture and product formulation, but it must be cooked to a predetermined temperature to ensure food safety and product quality. The cooking temperature typically ranges between 240 degrees Fahrenheit to 250 degrees Fahrenheit. After cooking, it's crucial to rapidly cool the tuna to prevent overcooking. Cooked tuna is cleaned again to remove the spines and bones. Some processing facilities may utilize byproducts from tuna processing for purposes such as fish meal, fish oil, or pet food. In this way, not only is it used to revalue the surplus material, but it also works under a circular economy, taking advantage of all the fish to avoid the contamination derived from its waste. After this point, there are two widespread ways of storing the product: in glass jars or canned. The different portions are marked so as to know to which lot they belong and in what quantity they should be placed in their containers. Tuna fillets may be portioned into uniform sizes and shapes to meet customer specifications and market demand. Portioning also allows for efficient processing and packaging of the tuna. Portions of cooked tuna and any additional ingredients are carefully measured and dispensed into each jar manually to avoid damaging the portions. After filling, metal lids are applied to the filled jars to create an airtight seal. The lids are typically made of metal and may have a plastisol lining to provide a secure seal. Finally, all the jars are labeled for further selling, putting an end to the elaboration process. In the case of canned tuna, the cooked and cooled tuna is portioned and filled into big cans. The process begins with prepared big cans being conveyed to the filling station via a conveyor system. Again, additional ingredients such as vegetable oil, water, salt, or flavorings may be added to the canned tuna depending on the desired product formulation before sealing them. Finally, sealed cans of tuna are subjected to heat processing, also known as retorting, to ensure product safety and achieve shelf stability. This also helps destroy any harmful bacteria and enzymes. With the leftover tuna from the large pieces, a compressed mass is made so that it can be pressure canned in smaller cans. During the entire process, hygiene and sanitation are paramount to prevent contamination and ensure food safety. Before the heating process, the filled and sealed cans of tuna are loaded onto racks or trays and arranged in retorts, which are large pressure vessels used for heat processing. After heat processing, the cans are rapidly cooled to room temperature with fans to prevent overcooking and ensure product quality. Cooled cans are then labeled with product information such as the product name, ingredients, nutritional information, and expiration date. The sea diamond is one of the most economically significant fish species globally, valued for its nutritional benefits, versatility, and market demand. The economic implications of its production are multifaceted and have a direct impact on several sectors. Tuna fisheries support livelihoods in coastal communities worldwide, providing employment and income opportunities for millions of people engaged in fishing activities. Import-dependent nations rely on imported tuna to meet domestic demand, while exporting countries seek access to lucrative markets for their tuna products. Indeed, tuna production carries far-reaching global implications that extend beyond economic considerations to encompass environmental sustainability, food security, governance, and international cooperation. Balancing the social, economic, and ecological dimensions of tuna production is essential for achieving a sustainable and equitable tuna industry that benefits present and future generations.